Understanding how vegetation is classified in the Dandenong Ranges National Park and the condition that it's in is essential for good policy and land management planning. In Victoria, vegetation is typically classified using the Ecological Vegetation Class or the EVC system. This system groups plant communities based on their structure, dominant species, and environmental conditions like soil type and rainfall. In the Dandenong Ranges National Park, some of the most common EVCs include cool temperate rainforest, wet forest, shrubby foothill forest, and heathy woodland. Each of these has different ecological characteristics and management needs. For example, cool temperate rainforests are fire sensitive and typically found in deep sheltered gullies, while wet forests dominated by Eucalyptus regnans is fire dependent and thrives on fertile soils. In terms of conservation status, many of these EVCs are considered endangered or vulnerable in the region. The, the Department of Environment, Land, Water and Planning has assessed the quality and extent of these vegetation types in various studies and maps projects, including the Biodiversity Interactive Map, known as the BIM, and NatureKit platforms. These assessments show that although large areas of native vegetation remain, many patches are degraded, especially near roads and visitor areas. Weed invasion, path logging, and human disturbances have all reduced the quality of understory vegetation, even in areas where the tree canopy appears intact. Classifying vegetation in the Dandenongs isn't straightforward. One of the biggest challenges is the fine-scale mosaic of plant communities. Because the park has steep terrain, changes in slope, aspect, and soil type happen quickly over short distances, leading to small overlapping vegetation patches. For example, a ridge may support drier Eucalyptus obliqua forest, while just a few meters downslope the vegetation shifts to a fern-rich rainforest gully. This was very evident in the many visits that I've made to the forests. These rapid transitions can make accurate mapping and classification difficult without detailed ground surveys. Seasonal changes, fire history, and post-disturbance regeneration stages also influence what vegetation is visible at any given time. Learning about rainforest and grassland vegetation types throughout the weeks 11 and 12 has helped me to compare and observe similar ecosystems in the Dandenong Ranges. In dry environments, boundaries between vegetation types are often broader and more influenced by soil salinity, water availability, and temperature extremes. These systems may be easier to map at broader scales, but harder to survey in terms of species richness, especially in drought years when many plants are dormant or absent above ground. In contrast, the moist, temperate environment of the Dandenongs supports high plant diversity and dense vegetation year-round. But this makes distinguishing between closely related EVCs and identifying understory species more difficult without experience or detailed guides. From a policy and planning perspective, these challenges mean that adaptive and site-specific management is key. A kind of one-size-fits-all strategy won't really work across a landscape as complex as the Dandenongs. Management plans need to account for subtle environmental gradients, as well as past land use and fire regimes, while also being flexible enough to respond to climate-driven changes in species composition. Conservation efforts must also include ongoing monitoring, using both traditional ecological surveys and new tools like remote sensing to track changes in vegetation quality over time. In summary, vegetation classification and conservation in the Dandenong Ranges requires close attention to detail, local knowledge, and flexible policies that recognize the park's natural complexity. Understanding these systems help ensure that the park's plant diversity is not just admired, but actively protected for future generations.